All right, let's dive straight in. Today we're looking at something really interesting in AI video generation.
Yeah, it's moving so fast.
It really is. So you've probably seen the buzz around models like Sora, VEO2, impressive stuff.
Definitely.
But often, the way they work is by generating the whole video clip at once.
Right, the whole sequence, which, well, it can be slow.
And not always easy to tweak, is it?
Exactly. So your goal in this deep dive, if you like, is to get your head around a new approach pretty quickly, one that might change things.
Okay.
We're talking about CausVid. This comes from some really sharp research out of MIT, CSAIL, and Adobe Research.
MIT and Adobe, okay.
Think of this as your quick guide to maybe the next step in AI video.
And our info comes straight from the reports on their work.
That's right. Direct from the researchers.
What really grabbed me initially was the contrast, between those big diffusion models that do everything at once and CausVid's approach. It seems more, I don't know, layered for building the video.
Yeah, it's a different philosophy. What's really fascinating, I think, is how CausVid tries to blend the detail and quality you get from diffusion
Right, the realism.
with the speed and agility of another technique. The real kind of aha moment is seeing how they combine the strengths of both.
Okay, so who's actually behind this? You mentioned MIT and Adobe. Is it a big collaboration?
It is, yeah. Researchers from MIT, Adobe, and also XAI are involved. Key people like Professors Bill Freeman and Fredo Durand at MIT.
Okay,
And Tianwei Yin is also a lead author. It's quite the lineup.
sounds like a powerhouse team. So what's the core idea, this hybrid approach?
At its heart, yeah, it's this innovative hybrid system. The analogy they use, which I think is quite helpful, is a teacher and a student.
Teacher and student, okay.
So you have a powerful diffusion model that's the experienced teacher, and it trains a different type of model, an autoregressive one. That's the fast-learning student.
Right, so the diffusion model teaches the autoregressive one. How does that work exactly? What's the student learning?
Well, the teacher, that diffusion model, it already knows how to make things look good, right? The detail, the consistency.
So the quality.
Exactly. It gives the student a kind of master class in that. Then the student, the autoregressive model, learns to predict the video frames one after another, sequentially.
So step by step.
Precisely. And that step-by-step prediction is what makes it so much faster. It's like you get the quality assurance from the teacher, but the speed from the student's method.
So diffusion sets the quality standard. Autoregression delivers it quickly, frame by frame. Okay, I think I get that. What are the big wins here? Why should we care about this method?
Well, the first one is just raw speed. It's dramatic.
Dramatic.
CausVid can generate videos in seconds, literally seconds. In their tests, they found it was up to 100 times faster than models like OpenSora or MovieGen
100 times.
for creating 10-second high-res videos, yeah. That's not just a bit faster, it's a game changer.
Wow. Okay, speed is huge. What else?
The second big thing is flexibility. Interactivity, even.
How so?
Because it's building frame by frame, you can actually give it new instructions while it's generating.
Wait, really? Mid-video?
Yeah. So imagine you start with a prompt, like a man crossing the street.
Okay.
And then partway through you add, now he writes in his notebook. CausVid can apparently adapt to that on the fly.
That's incredible. So it's not just fire and forget. It can react.
Yeah.
What about the actual look of the video, though? Does speed hurt the quality?
Well, according to the research, no. It seems to manage both. The videos are described as stable and realistic. That teacher model's guidance seems crucial here. It keeps the student on track, ensuring the visual accuracy stays high. It avoids that flickering or weirdness you sometimes see with faster methods.
So speed and quality, that's the holy grail, isn't it?
Pretty much.
The reports mention some cool examples, like a paper airplane turning into a swan.
Yeah, and prehistoric mammoths in the snow, things like that.
That shows some real creative potential beyond just basic scenes.
Exactly. It suggests it's not just about replicating reality perfectly, but enabling new kinds of visual ideas that were maybe too slow or fiddly to create with AI before.
And it's not just for artists or filmmakers, right?
Yeah.
The sources talked about practical uses, too.
Oh, definitely. Things like synchronizing translated audio with video for live streams.
So lip syncing on the fly for different languages.
Potentially, yeah. Or generating new scenes or assets for video games much more rapidly.
That could speed up game development hugely.
Or even creating realistic training simulations. Think about training robots. You need lots of varied interactive video scenarios. This could help generate that.
Okay, so we see the what and the why.
Oh.
Let's dig a bit deeper into the how, the science behind it. You mentioned the architecture.
Yeah, so it cleverly combines a pre-trained diffusion model, one that's already learned a ton about images and video, with an autoregressive framework, which is kind of similar to what powers many of those text AIs like GPT.
Okay, so image smarts meet sequence smarts.
Sort of, yeah. But the key is how that teacher diffusion model guides the student autoregressive one during training.
And that guidance is what stops things from going off the rails visually, prevents those errors building up frame after frame.
Exactly that. It stops that error accumulation problem. The teacher is constantly giving the student feedback, little corrections, examples of what good video looks like.
Right.
So the student doesn't drift into generating visual nonsense as it builds the sequence. Each frame stays grounded.
Okay, that makes sense.
Yeah.
It's a continuous quality control during the build.
You could put it that way. Traditional diffusion models, they often start with noise and refine it. Autoregressive models predict the next thing based on the last thing. CausVid sort of gets the diffusion model's global understanding to help the autoregressive model's step-by-step process.
So how did it actually perform in tests, head-to-head against others?
The results look pretty strong. For those 10-second high-res videos, it reportedly beat competitors on both speed and quality metrics. And it seemed better at generating longer videos, too, like 70 seconds. It held together better.
Any big benchmarks?
Yeah, there was one mentioned with over 900 text-to-video prompts. CausVid apparently scored highest overall.
Highest. In what areas specifically?
Particularly in image quality and how lifelike the human actions looked.
Interesting. But didn't the report say something about users sometimes preferring the student model's output on its own, even without the teacher's final polish?
Yeah, that was an interesting finding. It raises a point about what people value.
How so?
Well, the full teacher-student combo might offer slightly more visual diversity in theory, but users in some tests actually preferred the output just from the trained student model.
Why?
Because it was still super fast and the quality was consistently high, very stable, maybe slightly less varied than the absolute best the teacher could do, but the speed and reliability won out for many users.
So maybe consistency and speed are sometimes more important than maximum possible variation.
It could suggest that, yeah, a trade-off users are willing to make. Practicality matters.
Makes sense. There was also an outside expert quoted, wasn't there? Junyan Zhu from Carnegie Mellon.
Yes, his perspective was included.
What did he make of it?
He basically confirmed that this approach really does make video generation much more efficient. He pointed to the potential for faster streaming, more interactive applications like we discussed, and maybe even, interestingly, lower carbon footprints because it's less computationally intensive.
Lower energy use. That's a big deal for AI development.
It really is, and it seems this research isn't just happening in a vacuum. It's got some significant backing.
Who is supporting it?
Organizations like the Amazon Science Hub, Adobe, Google, even the U.S. Air Force Research Laboratory.
Wow, that's quite a list. Suggests they see real potential here.
Definitely. It signals that this is likely more than just an interesting academic paper. It has practical legs.
And people can see the technical details soon.
Yeah, the findings are set to be presented at a major conference, the Conference on Computer Vision and Pattern Recognition, CVPR, in June.
Okay, good to know. So let's try and wrap this up. If you had to boil it down, what's the single biggest takeaway from CausVid for you?
For me, the key thing is this smart combination. It's taking the best of diffusion models, the quality and the best of autoregressive models, the speed and sequential nature, and blending them. It's not just faster video, it's potentially more interactive, more efficient video without that quality hit.
And looking forward, where does this lead? What are the next steps or implications?
Well, you can imagine pushing for even faster speeds, obviously. Longer videos, too, maybe more complex scenes.
Yeah.
And perhaps developing more specialized versions for specific industries, like really tailored tools for robotic simulation or game asset creation.
And maybe making these powerful tools more accessible.
That, too. If it's more efficient, maybe it lowers the barrier to entry for high-quality AI video creation.
Okay, so here's a final thought for you, our listener, to chew on. If we can generate video this quickly, this interactively, how might that change things? Not just how we make videos, but how we consume information, how we experience entertainment.
Right. It could shift from passive viewing to something much more dynamic. A world where video is perhaps co-created or adapted in real time.
Definitely them to think about.